Hey, Vlad here, DependencyGraph.com. Welcome to another video. In the previous couple of videos, we added a database to our to-do app, and today we're going to add an HTTP layer on top. Let's get right to it. Alright, now we're faced with a similar issue as the last time. We need a library that is written with app in mind, or otherwise we will end up rewrapping a lot of things. And in the Scala ecosystem, HttpApp is a safe bet, so we're going to stick to it. Now, in the previous persistence-related videos, we wrote the queries first, then we interpreted the entity gateway with the Postgres entity gateway, and then we wired the entire app together. With the delivery layer, we're going to proceed in reverse. We start with all the wiring first, and then write a very simple HTTP route that will be able to display all the to-dos. And the reason I'm doing this is because the HttpApp or the delivery layer is going to be the most complicated one, and so I want you to see the full picture first. Same as in this related videos, I should probably mention that this is not going to be a full-blown HttpApp tutorial. We're just going to grab the pieces that we need and go from there. All right, let's start by adding the necessary submodules. If we go to the build, we're going to see that we have our aggregated build. And so we have, for example, the persistence layer and we have the persistence Postgres skunk. And so we're going to mirror that for the delivery. Okay, so we have the delivery, and now we're going to have delivery HttpApp4s. Okay, we're going to add a couple of more. So this one is the main and main Postgres skunk. So again, we're going to add like a mirror. Okay, so in fact, I'm going to add it like before over here. Okay, so we're going to have main delivery HttpApp4s. All right, and we're going to have one more that uses both the database and the HttpApp4s layer. Okay, so I'm going to duplicate this one, go down like this, come over here. I'm just going to add Postgres skunk. All right, now since today we're going to add only one route, the one that will be able to display all the to-dos, we're going to start with the database layer, so was the one that has both the HttpApp4s and already talks to the database. And the reason for that is because, we can't add to-dos yet, right? So we're going to rely on a database which already has a couple of to-dos, and we will also be able to, to switch to the Rail main, to the regular main app, or I'm sorry, to the regular, main Postgres skunk app if we wanted to add some to-dos. All right. And then by the end of the video, we will copy like one or two files, and then we're gonna get this which one? This one. We're gonna get it pretty much for free. All right. Cool. So now let's go and add them. So we're gonna start with the delivery HttpApp4s. So we're just gonna go down to delivery, which is over here. We're just gonna copy it, go down over here, paste it like this. So we're going to call it and delivery HttpApp4s, and over here we need the backticks because we cannot have hyphens in the variables. We're going to add the HttpApp4s dependencies a little bit later. For now, we're just going to leave it as is with just gets effect. All right, so let's scroll down to main. Okay, let's just copy the main. So we have main like this and paste it over here. So this one is going to be main HttpApp4s like this, backticks over here. This one will have the backticks over here, and it will depend on the delivery HttpApp4s like this. Okay, and we're going to let's grab this one, maybe paste it over here like this. So this one is going to be main HttpApp4s like this. Forgot to add it over here as well. Main HttpApp4s Postgres skunk. Okay, and it's going to have the dependency on both of them, right? So delivery HttpApp4s like this. All right, and notice that we're repeating like these library dependencies, right? So these are basically the effects. We have them like a bunch of times. So what I'm going to do is I'm going just to grab this sequence, and I'm going to go down somewhere, and I'm just going to have a lazy val, and I'm going to call it effects like this, and I'm just going to paste it over here. And maybe we should also put cats effect in there because it's technically also an effect. Just for completeness sake. So let's go grab that, go down, put it in, make sure everything is sorted like this. By the way, notice this, this arrow highlighting over here. I recently installed a plugin called, how's it called? Arrow lens, right? So it's basically displays the arrows a bit more vividly, right? So they're a little bit more in your face. Okay, so now we can go and use these effects. So over here, instead of this, we're just going to do. In fact, let me mark all of them like this. I'm just going to paste that, and there we go. So we're just going to join the lines, and same over here. Just join the lines. And same over here, join the lines. Same over here, join the lines. Right, so we have 4 main methods already. Yeah, import the changes. Okay, I was kind of hoping that Scala FMT would fix this for me, but it didn't. Not sure why. Okay, I guess I have to do this manually. Let me do this, mark all of them, do that, do that. Okay. Import partially failed. Oh yeah, because I don't have this comment. That's why Scala FMT didn't do anything. Okay, right. So this should be fine now. Import all the changes. Let's remove this one. Okay, let's show the logs. Let's see how well it's doing. All right, there were still some errors. What did it say? Not found value. Main delivery HTTP4s. Okay. 32 main delivery. Okay, it should be HTTP4s like this. All right, let's not import it. Let's see if SPT is happy. Let me just do this. All right, come on. Okay, I still made a couple of mistakes. Okay, so not found main delivery HTTP4s. So I did the same mistake over here. HTTP. Right, so I'm like the way I call them is I always say like what they do and then which library I'm using for it. Okay, so for example, Postgres, skunk. Okay, what else? Not found value. Okay, hold on. What the hell? Okay, delivery HTTP4s. Okay, so main HTTP4s. Oh, I put delivery in there instead of HTTP. All right, so main HTTP4s, main HTTP4s. Okay, I like this. Retry. All right, great. Oh, by the way, and we're also getting this, there may be incompatibilities among your library dependencies. There is a way to suppress these warnings, and these warnings are rarely necessary. Usually, like if you have an issue with dependencies, you will just type in evicted like this, right? And it will show you what's up. So what we're going to do now is we're going to remove the warning, but you will still be able to type in evicted, okay? So what we need to do is we need to go down to the common settings over here, and I'm just going to add it, let's say over here. Okay, we just need to say update eviction warning options, and the option is eviction warning options dot empty. All right, so let's see if I made any mistakes, and it looks like I didn't. And I'm also going to copy this and I'm going to paste this in the plugins as well, because over there I also don't want to see any eviction warnings without the comma, like this. All right, retry. Okay, I believe everything is happy now. Okay, so we can finally import the build like this. Close that. Close that. We don't need any of that anymore. Let's go over here. All right, so to recap, we have 4 main methods. The one that doesn't use any database, the one that is not exposed over HTTP. Then we're going to have a main method that it is exposed over HTTP, but it doesn't have any database. It uses the in-memory database. Then we have the main method that uses a database, but it's not exposed over HTTP. And then we have the main method that will have everything. All right. So remember how in persistence over here we had a session pool, okay, which basically was creating a connection to the database. So we're going to start with sort of like a mirror for that for the delivery layer, and it's going to be called servers. So we're going to go into the delivery HTTP4s, right click over here, new file, source main Scala com dev and sideview to do server dot Scala. Like this. All right, as you know, I prefer to have my packages like this. Okay, so we're going to import cats right away. I'm going to do a trade server. which is going to be parameterized with an f over here. It's just going to have a method called serve, like this. All right, so we're going to have object server, and we're going to have DSL as always, which is going to use sync, and it's going to expose an f of server of f, right? Because we want to, every time we're creating like shared resources like this, we need to delay them right away. Okay, so we're going to do delay, and we're going to say new server for f, and we're just going to override val serve, which is going to be just an f of unit. Okay, and later we're going to implement it somehow. All right, just like this. Server, server like this, come on, server like this. There we go. Val server overrides nothing. Okay, serve. Okay, I don't know why typing is so hard all of a sudden. Okay, so this is all that we need for now. The next thing that we're going to do is we're going to go to the regular main over here. Now, actually, let's go to the one that is over here. Okay, so we're going to go over here. It has the main, it has the program. So if we click in there, it's the one that creates a session pool, creates the controller, creates these guys. We're not going to use these guys anyway. Let's go and we'll probably need to create it first. Okay, so it's going to be over here. I'm going to say new file, and it's going to be source main Scala com dev and side view, and this one is going to be in to do, but it's not going to be in CRUD, so it's just going to be like this program.scala. All right, so we're going to grab this one, just copy paste the entire thing. Okay, like this. So in this particular case, we're not going to expose it over the terminal, right? It's going to be HTTP, so we don't need the console, we don't need the random. Okay, so let's just remove these two guys. This controller over here, let's comment it out for now, like this. And so the program is not going to come from the controller; it's going to come from the server. Okay, so we're just going to do server. We don't need the val. In fact, I believe Scala FMT should remove the val, so let's leave it in there. Server. I'm just going to say server.dsl for now. It doesn't want any parameters, and we're going to do like this, server.serve. Okay, so it's kind of like very similar to what we have over here before. Val keyword for comparisons and support. Just remove val. Oh, they removed it in 2.13. Interesting. All right. Cool. So let's talk about controllers, because in order to construct a dependency graph, which we can pretty much go and copy paste right now, but we would need to have a notion of a controller. So for that, let's take a look at the controller that we already have. So in the regular delivery, if we take a look at the CRUD controller, then we're going to see that it's basically an application that has just one method called program, which returns an app of unit. But what's inside of it is pretty much a router, right? So there's pretty much this menu that decides which method to call. So we're going to have a similar thing in the HTTP layer. So we're going to go over here. We're going to say new file. This one is going to be under CRUD, and it's going to be called controller.scala. All right, so it's going to be like that, and it's going to be like that, and it's just going to be a controller. Well, we can pretty much copy paste it actually. So if we go over here, we can pretty much copy paste it like this. All right, so in this particular case, it's going to be the HTTP route, so it's not going to be like an f of unit. Okay, so for this we need to start using HttpApp4s. So let's go and add the dependency first. Okay, so we're over here, so we need to go to org. Okay, so we have org au. Okay, so it's going to be over here. Okay, so we're going to have case object HTTP4s. Okay, so we're going to have HTTP4s DSL. Okay, and we're going to use a tiny helper method called dependency. Okay, it's just going to be defined over here, tiny private def dependency. We're going to give it the artifact like this. It's a string. It's going to return a module ID, which comes from SPT, and it's going to do org.http4s like this, and it's going to do http4s $artifact, and the version that we're going to use is 21.7, which came out actually a couple of hours ago, so there might be dragons. Okay, so we're going to do this just for now like this, not now. So in just a couple of minutes, we're going to add more HTTP4s dependencies, and all of them are going to have this version. This is why I'm using the private def over here. Okay, so let's go back to the build. I'm going back to the build like this. So we need to find delivery for HTTP4s over here. I'm going to do comma over here because it's going to be org HTTP4s HTTP4s DSL. Okay, the one that we just created over there. Where is it? Over here, this one. Okay, so everything is fine with SBT, so we should go and import the build. There we go, importing the build. So while it is importing, we can go to the controller and we're going to change this, right? So instead of like this, we're just going to call it routes, and it's going to return HTTP routes of F. Okay, very, very similar. We need an import, so we're going to import cats right away, and we're going to import org HTTP4s as well. Like this. Okay, it's going to be less red once Bloop actually finishes importing and starts. It's going to start recompiling. So let's just continue. So we're going to have our object controller like this. In fact, we can pretty much copy paste stuff from the old controller. So we go to the old controller, which is this one. We can pretty much just grab maybe this over here, like all of that stuff. Just put it over here. Okay, it's just going to be called routes now. We're going to close the brace, and it's going to return HTTP routes of F like that. There we go. We don't need, okay, we still need the pattern, we still need the boundary, you know, later we're going to need it. We don't need the console, we don't need the random. And HTTP4s comes with a tiny helper, which is called empty, like this. And missing closing brace. Okay, let's do one closing brace. Okay, there we go. Datetime formatter. We need to import. Let's put it up like this. All right, it looks all good. Let's remove that because we don't need it. Okay, we still need an applicative. Okay, applicative. All right, and there we go. I'm not sure why this is red. Let's reopen it real quick, and it's not red anymore. Great. So now we can go and construct a dependency graph. So let's go and steal the dependency graph from the Postgres layer. Okay, so we're going to go dependency graph. So this is the regular one. This is the one with skunk. Okay, like this. So we're just going to collapse the whole thing. In fact, hold up. Show me this one. Okay, so it's over here. So we need to go over here. And we have then inside we have to do, okay, we still need CRUD. Okay, so we're gonna do, let's do new folder CRUD like this. Now we can just copy the entire file, click over here, paste it over here. All right, so this is the new one. Let's close the others. Okay, so this is the new one, like similar to before. We don't need the console, we don't need the random, we still need all of that stuff. And yeah, so we don't need the console, we don't need the random. Is that already enough? Yes, it's already enough. That was kind of simple, right? Okay, so now we can go back to the program and at least uncomment this line. Okay, so we have program in this one, the very long one. So now at least we can uncomment this line like this. Again, we don't need the console, we don't need the random. Okay, but everything else should be fine. All right, now HTTP4s has a notion of an HTTP app, and what it does is if you go back to the controller, this one, it basically takes these routes and at the very minimum it seals them by basically adding another route which would which would be triggered if the route doesn't exist, and it's just going to return a not found, a 404. Okay, so what we're going to do now is we're going to go over here at the same level where we have the server, right? So it's not in CRUD. We're going to go and add a tiny helper, basically, that will assemble the HTTP app. We're going to complete it a little bit in the next video, but for now, it's just going to pretty much seal the routes, and that's it. Okay, so we're just going to call it HTTP app, and note that HTTP app, the trait HTTP app, or actually it's type alias, but it doesn't matter. It already exists in HTTP4s. Okay, so what we're going to do here is we're just going to have an object HTTP app. Okay. All right, so let's go and do that like this. Okay, so all it's going to do is it's going to have a DSL, which is going to need an effect concurrent. Okay, so it will just take a bunch of routes, and we're going to use a non-empty chain of routes over here, HTTP routes of F. Okay, so for this we need cats data. Okay, and in general, we're probably going to need cats, and we're probably going to need import cats implicits. Okay, and since we're using HTTP routes, we might as well import org HTTP4s, and we're also going to need org HTTP4s implicits like this. Okay, so all it's going to do is going to construct an HTTP app. And again, note like this HTTP app, it is already present in HTTP. Once I finish typing, we're going to jump in there and check it out. Okay, so all it's going to do is going to take all the routes. It's a list, right? So it's going to do a reduce left, and there is a helper, that comes from these implicits called, I have no idea how it's called. It kind of looks like this ship from Star Trek. I believe it's actually called something like called something similar. What is it called? I'm not a Star Wars fan. I don't know. Anyway, so we're just collapsing all the routes into pretty much one thing, and then we're gonna call again, like from these implicits, we're gonna call or not found. Okay, come on, Bloop, do something for me, metals. Okay, or not found. Okay, like this. So this is pretty much like at the very minimum, this is all that it's going to do. It's going to add this route, which is going to catch the the underscore basically, right? So if we don't meet any routes, we're at least going to return an or not found. Okay, so now we can go back to the program and we can construct this thing. Okay, so we can go over here and we're going to say that it's going to be an HTTP app. Okay, and we're going to use an equal sign, okay, because it doesn't return anything, wrapped into an app. It just goes and returns an HTTP app of app. Oh, by the way, I wanted to jump in there. Okay, let's just a type alias for this long thing. Okay, right. So what we're doing, we're going over here, and we're going to say HTTP app DSL, and I'm going to indent it like this because I kind of want to. I want you to have the feeling how this thing is going to grow. Okay, so we can go to controller and get the routes now, right? Because remember, the controller, it now has the routes, right? It sort of returns you like this program thing. Not found value in an empty chain, which means we need cats data. We're going to remove this non-empty chain in the next video, by the way. All right, like this. Okay, so instead of doing like controller.program, we're doing controller.routes. We're just passing it into this HTTP app DSL helper, and it's giving us the HTTP app. And what we're going to do with the HTTP app, we're going to stick this into the server.dsl. Okay, so let's go into the server DSL. Let's just click over here. Okay, so we're going to say that there's going to be a parameter list over here, and it's going to be an HTTP app, which is going to be an HTTP app of F. Just like this. All right, probably need an import. What? Oh, why did it do it like that? Why didn't it import it? HTTP4s. Let's just do underscore. All right, there we go. Okay. What else? Where are we? Oh yeah. So now in the program it fails because it wants it, right? So we're just gonna give it to it. Okay. HTTP. Great. Okay, so the next thing that we're going to do is we're actually going to finish the server over here. And for this, we need our next dependency in line, which is going to be dependencies. Okay, over here, we're just going to copy this one, paste it over here. And this one is going to be called Blaze server, like this. Okay, and B comes before the D. So let's actually go and put it over here, like this. All right. Okay, cool. So now let's go and use it. No, not now. Let's go to the build. Delivery HTTP HTTP4s, and it is going to be here. Blaze server, like this. All right, let's see if SPT is happy. Seems like SPT is happy. I think it loaded fine. Yeah, there we go. Okay, so now we can import the build. We can go back to the server. Now, in the latest HTTP4s versions, they changed the factory method that creates the Blaze server, and they changed it in such a way that it receives the execution context explicitly, which I like, by the way. Okay, so all we need to do is we need to go and add it over here as a parameter. So we're going to have execution context over here. It's going to be execution context. Okay, comma like this. So we need to import it. Yes, Scala concurrent. Let's just do that. Scala should be over here. All right, cool. And by the way, usually, like if you write your application based on the futures, then you end up passing this execution context all over the place. And so, it's a common thing to call it just EC because you end up passing it all over the place. This happens because features are eagerly evaluated, which means that every time you touch them, they need to run right away. Like every time you map or flat map or even just create one, unless it's already successful one and you're just wrapping it, right? So you need this execution context all over the place. In a pure functional programming application as we're having right now, you actually don't. So this is going to be pretty much the only place where we're going to use it, right? So we're going to create it in the main, we're going to pass it into the program, and then the program is going to pass it over here. In fact, let's actually go and fix this compilation error because this is what it's complaining about, okay? So we're just going to put it over here. I did not copy the parens, okay, like this. Import, so I have Java, import Scala, concurrent, and we have a comma over here. So let's just remove it. Okay, so we're just gonna pass it over here. Was it the first one? What was the first one? Was it the first one? That doesn't matter. Execution context, like this. Okay, so now everybody is happy. Okay, great. So we can go and now we can finish writing the servers. So we can go over here and we're just going to say Blaze server builder like this, and as its parameter it wants the execution context. Let's see if I can import it already like this, and it looks like I can. All right, yeah, that's fine. Let's leave it like this. It's actually a perfect place. Okay, so all we need to do is we need to go and we need to say bind HTTP. Over here you can pass some parameters to specify the port. The default port is 8080 and we're fine with that. Okay, so now we just need to call with HttpApp and just give it the HttpApp. Okay, now we need to serve it, which is going to give us an FS2 stream. We're going to compile it and we're going to drain it. This is how we're getting out the app of unit. Okay, so now we're seeing our famous divergent implicit expansion, which means that we need to specify the f somewhere so that we see the proper message like this. Cannot find implicit value for concurrent effect. All right, you should have said so. Okay, so this is going to be effect concurrent effect. Let's see if this is enough. Okay, now it also needs the timer effect timer like this, and all right, what does it say now? Value server is, no, it's serve, not server, serve, like this. All right, so now it only doesn't compile in main. For now over here, okay, so now we actually don't need the f, and we don't need the sync because like these guys, they have a dependency on sync as well. Okay, this is all we need: concurrent effect and timer, and we don't even need to understand what they're doing. This is the entire server. Okay, let's go back to the program. And it probably complains about the same things. Okay, so we have concurrent, and let's do concurrent effect. What else? Timer. Okay, I believe we don't need concurrent if we have concurrent effect. I don't remember. I think it's like this. Yeah, it's good. Okay, let's also sort them like that. I kind of like to sort them. All right, cool. And let's also inline this thing. I don't need this. I kind of don't like to have like equal sign in the for comprehension. It's so hard to miss accidentally. And this looks weird. Let's go and curry the function over here. All right, so let's just close, open like this, and now we can go and do that and open the curly brace over here and close it like over here and remove this one. I believe it should look better now. Yeah, it looks good. Okay, so we're creating a server by giving it an execution context, and over here we have this thing, right? And when this thing is going to grow, we're just going to have a bunch of controllers and a bunch of routes. You're just going to pass them in over here. Okay, let's remove that nastiness. All right. There we go. Nice. All right, so we're pretty much done with this whole thing, right? So we have the program. We go to the dependency graph, and it has everything that we need. It jumped again into the wrong one. I'm not sure why Metal sometimes jumps into the wrong one. I actually wanted it to jump into this one. Okay, so this one is already working fine. Controller DSL. Okay, this one has empty routes, but it's fine for now. Okay, so all that is left to do is to have the main. So let's go and grab the main from the one with skunk. Okay, so let's go grab this one. Okay, we have crowd run program. Okay, so we can just grab the file, click over here. Okay, great. And it's going to almost compile. It just said it needs the execution context. Okay, so we were using it like this. So it's just gonna cat it out and say execution context, and we're just gonna put it like before everything. Okay, so it's just gonna be execution context. It is going to be this of type the same thing, just the E is capitalized. Okay, and we just need to pass it along to this guy. And okay, it still wants a timer. Okay, so we need to also create a timer. Should be simple. So we're going to go implicit val timer. It's going to be a timer for IO. Whoa, timer for IO equals IO timer execution context. All right, so this part is happy. This part is almost happy. We need to give it the execution context like this. Okay, and this part is almost happy. For this one, we need a little bit more. So we need to go and import Zio interrupt gets implicits. Okay. By the way, Zio recently had a 1.0 release, and I have a commit that is between the previous video and this one. Maybe I should actually show it to you real quick. So we have the commits. I have like this one was the refactoring. It's called refactoring, but it's actually just the update of the dependencies, right? So Scala FMT, Scala new version of Scala test. What else we have? Scala FMT. Yeah, so over here, Zio 1.0 came out. What else? Something major change. Yeah, new version of Skunk. Right, so that's all, right? I just updated in dependencies, right? Okay, so let's go over here. Where were we? I jumped into dependencies. Okay, so we need this, and we basically just need to wrap this thing. Okay, so first of all, it will need the execution context anyway, right? Execution context. Okay, so now it says that it is missing the concurrent effect. Okay, so we just basically need to wrap this thing into Zio runtime default unsafe run like this. Okay, so we just need to remove this, put this inside. Okay, so I'm realizing now that I basically just flip the braces. What I wanted to say is that we need to wrap this thing over here, right? We need to wrap it into Zio task concurrent effect with, and then we're going to have access to an implicit parameter that we're actually not going to use, concurrent effect. Okay, it's implicit, right? And just put this thing inside. Okay, and it's going to be fine now. In fact, it's going to be so fine that we don't even need to specify the type over here. We will though, just for the symmetry purposes. Like this. Okay, so this is the entire main, same as before. We're just throwing a random number, picking our effect type. The first one is cats effect, then Monix eval task, and then then the Zio task. All right, so let's actually go and run this thing. So as a reminder, I'm always using a plugin called Revolver, which is over here, which it gives us access to the main-http-4s delivery Postgres this one. Okay, so instead of just run, or instead of just R, which is just now as for run, we're going to say a restart. Okay, so the difference is that it forks the JVM, and so if we do something wrong, we just type in restart. It's just going to kill the JVM. We're not going to have like any unclosed sockets or anything like this. All right, so it's already running, and it says that we're just seeing like some errors because the we don't have any logger. We actually can go and fix it real quick. I kind of want to have logging for this, and we don't need it, right? So we can already go and I believe that I actually have port forwarding set up, localhost 8080. Okay, what's gonna happen? Nothing's going to happen. Maybe I turned it off. Yeah, I turned it off. Okay, so let's do it. Let's do it over here. So let me just click on. It should have shown me. Oh yeah, because we don't have the logging set up, it doesn't actually even show this to me. Okay, but still, let's go and run some browser. Okay, because we should already see and not found. Okay, let's start Firefox, and remember the last time I started Firefox. Okay, localhost 8080. There we go, not found, right? So this is happening exactly because we went to over here in HTTP app over here because of this. Okay, so it added this extra route, right? Because in our controller, remember, we don't have any routes. Okay, let's actually close this one. I'm gonna go over here. I'm gonna go to dependencies. The way that logging works is that this thing works even if the logging is not there because it's like a runtime dependency. Let me actually copy paste this so that we don't waste any time. So it's going to be called SLF4J. So it's going to be SC somewhere over here. Okay, SLF4J, and this is a Java dependency. So note that we have only one of these modular symbols. Not now. Let's go to our build, and let's go. And by the way, we can just stop this guy. We don't need it. All right. So deliver HttpApp4s, and let's go and add it to the main. I'm going to end up repeating ourselves. Okay, so this one doesn't need HTTP. This one does. Okay, so we're going to add it over here. I'm going to say settings, and it's going to be a library dependencies. I'm always using sequences, in case we would end up needing adding more. SLF4J, and we're just going to say SLF4J. Simple, like this one, and now I can copy paste this one, and we have another main that uses it, right, which is that one. Okay, there we go. Okay, so now if we do restart, SPT will notice that there is a change because in the file spt.spt we have this thing. So SPT noticed the change, it reloaded, and now we have some logging. Okay, so now we're seeing blah 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 HTTP4s, and now we're seeing that it's actually running over here, right? So now I can do alt click and it should open my default browser, which I actually believe is Chrome, and we're getting a not found. So we're pretty much done with this video, but it's kind of boring, so I want to add at least this one route that will just show us all the to-dos that we currently have in our database. So for this we're going to need Cersei, right, because the to-dos are going to come back as JSON, and I already have a playlist for Cersei. You can go and check it out. So I'm going to go and where is it? So it's going to be in org. No, it's actually going to be in IO. Okay, I'm just sorting them alphabetically. Okay, so we have IO mnemonics. So over here. Okay, so we're going to have case subject Cersei. Okay, and we're going to use Cersei generic. Okay, like this, and it's going to be. We're going to use the same trick because like most of the Cersei dependency, they have the same version. So I'm just going to go and it's just a pattern that I'm using. Over here, put it over here. Okay, so this is going to be IO Cersei, and this is going to be Cersei, and the current version is 13.0. Okay, so again, like today we're going to use only this one. We're not going to use more, but if you want to play around with it and you want to add more dependencies, and then you can reuse this tiny helper. Okay, so now we need to go to the build and find the delivery HTTP4s, which is this one, and we need to add IO Cersei generic. Okay, and actually I forgot one. We also need org HTTP4s Cersei as well. Let's sort them real quick. Like this. Great, so let's not forget to edit HTTP4s. Let's do this one, edit over here, and it's going to be Cersei, like this. Okay, let's kill this guy. Let's import the build. Oh, actually I shouldn't import the build when SPT is restarting, because sometimes it has like weird race conditions. Oh, SPT wasn't restarting. Okay, so let's allow Bloop to finish, and in the meantime, we're going to go and add another file called to do. So remember in Skunk, when we were actually, let me show this to you. So if you go to statement over here, this one. So in Skunk, we took the to-do that is defined like at the top in the domain, and because Skunk is so low level, it allowed us to very easily to like almost manually to define codecs. Okay, then I did not create this like a layer in between where I go from my domain objects to to whatever to Postgres objects. Okay, I just went like directly we wrote the codecs directly for them. In with Cersei we don't need any of that, so we're actually gonna go And I'm sorry, I said with Cersei we don't need any of that. With Cersei we don't have like this low-level access, and we don't need it, right? And therefore we're going to create a version of the to-do that is like more flat and more suitable for for working with JSON. Okay. In the meantime, let me actually go back to root and just compile everything because SBT needs to reload and stuff. Okay, okay, maybe it didn't. Great. So we're gonna go and collapse everything over here, and we're gonna go and over here, over here. Okay, so because the entity that we're dealing with is not even in the CRUD. Okay, so we go over here, then we're going to see that it's just in just like this. It's actually not even in to-do app because I never. Well, I did explain this in a couple of videos, but basically this whole thing is based on clean architecture. And in clean architecture, you have this domain logic over here, right? So this is business logic agnostic, so it's application agnostic, okay? Which means that we could write multiple apps and they would all reuse this to do. And this is why it's not even in the to-do package. Okay, so what we're going to do is we're going to go over here and create a new file, and we're also going to call it to-do.scala, like this. Okay, and so what we're going to do is we're actually going to put it into not just dev inside you. Let's actually create a folder here, and we're going to call it response. Okay, and because this response is actually particular for this to-do app, let's actually put it under to-do. Okay, so let's go and create to-do. Okay, oh, to-do already exists, so let's just move it over here and move this to-do over here. Okay, so this is now in ComDev inside you, like this, to do, and package response. Okay, so all we're gonna have over here is a flat version of the to do. Okay, so we're just gonna have a final case class to do. It's just gonna have an ID, which is gonna be a string. Everything is gonna be a string, right? Because everything is just going like straight to bytes and exposed as JSON. Okay, deadline string. Okay, this whole thing. Now, even though like Cersei can, can encode like a proper types, proper deadline and everything, we're just gonna do everything manually because I wanted to look very similar to what we had before. Okay, let's add a gazillion of imports. So we're gonna have Java time format date time formatter. Come on, help me. Formatter. This one, and we're gonna have IO Cersei. We're going to have IO Cersei generic semi-auto. Watch my Cersei videos to understand what's happening over here. Basically, we're using semi-automatic derivation to derive codecs instead of writing them manually. HTTP4s and HTTP4s Cersei. Okay, so we need to be able to convert this thing to JSON, and then we need to be able to convert this JSON into a JSON MIME type, and so we need HTTPS support as well. Okay, so all we're going to do is we're going to go over here. We're going to create a companion object. We're going to call it to do, like this, and it's going to have apply. And it's going to have a current function. The first one is going to want the pattern, which is DTF, which is this one. Come on, yes, perfect. And the other one is going to be the existing to do. Okay, and because we have like the name collision, which I created on purpose, we're going to do com dev inside you to do existing, like this. Okay, and it's going to give us this to do. Okay. By the way, you might want to do something like, let me create a little bit more space. You might want to do something like this, import com, and then rename dev inside you to domain, and therefore you will be able to do domain over here. Okay, I'm not going to do this, or maybe I will. Yeah, I'm gonna do it. I'm gonna leave it like this. Okay, so all we need to do over here is we need to do ID is going to be existing dot ID dot to string. Description is going to be existing data description, and deadline is going to be existing dot data dot deadline format with the pattern. All right. So again, like even though Cersei can actually right away turn a local datetime or something like this into JSON, I want to keep it similar to what we had like in the with the rest of the application. Okay, and also I think I mentioned this in the previous video. We're not concerned with the typical production level application issues over here, as you would, right? So we don't care about, the time zones. So, we just assume that everything is in the same time zone. We don't care about, millisecond versus nanosecond precision. We didn't care about this in the database videos either, because again, like, this is not the focus of this series. The focus is like how to basically build these gigantic, proper applications with the tagless final stop. Okay, so now we need to go over here and we need to derive an encoder. Implicit val. We don't need the entire codec. Okay, we just need to encode this thing into JSON, right? This is just a response, right? So this is why I call this package response. Okay, like this. This means that my folder is called incorrectly response, like this. All right, so yeah, so this is the encoder for to do, and for this we just need to say please derive encoder. Okay, derive, that sounds very Asian. Okay, derive encoder. Okay, so now that we have the encoder, we can actually have an entity encoder as well, which is going to have an f over here. It's going to be entity encoder for f, and to do, okay, it's going to be JSON encoder off. Okay, so this one comes from this needs to be a def. So this one comes from this import over here. Okay, great. So this is the whole thing, right? Just a couple of lines. It's basically just a to do and just a factory method to create it. And then we have the encoder, and we have the entity encoder that would take this and convert this into JSON, and then also wrap this into a proper response. Okay. So now all that is left to do is we need to go to the controller and add this one tiny route. Okay, over here. So right now we have only the empty routes. Let me add a bunch of imports over here right away. So we have this, and we're also going to use Scala util chaining. Scala util chaining. We have the cats. We have the cats implicits. We're gonna use the IO Cersei syntax because we're gonna grab our case class and convert it into JSON by saying as JSON. And okay, we have HTTP4s. We're also gonna have HTTP4s Cersei. Okay, and we're going to have HTTP4s DSL, HTTP4s DSL. Okay, so that we can actually write this DSL. Okay, so all we need to do over here is we need to say that we're not only returning a controller, we are returning a controller with the HTTP4s DSL for f, like this, like that. Paren over here, like that. There we go, compiles, great. So now instead of the empty routes, we're just gonna say off, okay? And we're going to say case get arrow to the right, this arrow, like this. I'm gonna say root / to-dos, then we're just gonna call show all. And in fact, if we go and we grab the show all from the original controller over here, show all, it's going to be very similar, right? So we're just going to grab this one, go back here, just paste it over here. Okay, so the only difference is that it's not going to be an f of unit, it's going to be f of response of app. Okay, and we don't have this like this display 0 or many thingy because we're not going to print anything out. Okay, so we're going to remove that, have that. Okay, so over here we're going to have the to-dos. Okay, over here we're going to have to-dos, and we're going to sort them by deadline. Okay, we're going to map them into response dot to do pattern. Okay, so this is a query function, right? So the to do comes in over here and gets injected over here. This is exactly why I queried it. So let me revert that part. Okay, so that I can just do that. Okay, and then when it comes out, we're just going to do as JSON. Okay, and then the entire thing we're just going to pipe into. Okay, so this is just a HTTP4s helper to construct this response. Okay, so all is left to do is to fix these guys. Okay, so it wants defer. Okay, so it wants defer, and what else? Flat map. So it needs a monad. Well, actually, maybe flat map is enough. Flat map. Is flat map enough? Applicative defer flat map. Did it compile? Let's see. Yeah, it's fine. Okay. Do we actually need? Oh, but we have applicative. Okay. Do we need applicative? Yeah, we do need applicative. Okay, so we might as well then grab the monad and defer. Okay, so defer and monad. Okay. Great. So this is our route, and if we go, do I still have the browser open? Okay, we need to launch it first. So let's go into main HTTP Postgres. This one, we're going to restart it. Okay, I actually don't remember if we have something in our database. So if we go over here, and we're going to do /todos, then we're going to see, yay, we actually have something in there. All right. Now we're not going to use the browser, right? This is ugly. And we're also not going to write tests. I haven't decided if we're going to write if we're going to end up writing tests, and but if we do, we're gonna do this in the very end. So for now, I have an extension called REST client, and also an extension. So what it allows you to do is that if you go over, let's just create it over here. We have a similar thing in the Postgres thing, right? So over here, we had this folder called Docker, and inside of it we had a client. So over here we're not going to have a folder, but we're just going to create over here a file. I'm going to call it client, and if it has the HTTP extension, and then VS Code will understand how to render it, and it will talk to this extension. Let me actually copy paste something from my script, which is going to be a comment over here. So this is how you can find this this extension. Okay. So what it allows you to do, first of all, it allows you to have variables, right? So we're going to have a variable called endpoint. It's going to be HTTP //localhost 8080 and /todos. Okay, so for now, this is the only route that we have. This is the only route that we have. Okay, let's have a comment over here. It's going to say show all. Okay, and if you have a get response, so you can say get, but for a get response you don't even need to. So this is how you access the variables. So you can say endpoint like this. Okay, so this is how you dereference this variable. Okay, so now I can just click over here, and it's going to send a get request to this URL, and it's going to render JSON beautifully. Okay, okay. So I don't want to leave it like this. I'm going to leave it like this. And by the way, it also understands the curl syntax. The full-blown curl syntax. So you could also do curl, and it's going to understand this, right? So as you can see. Right. It also shows you, like how long it took, the responses. It renders JSON beautifully. It has, it shows the same thing over here. Breakdown of response size, breakdown of the duration. It's a really cool and nifty plugin. Okay, let me revert the curl thing. Let's actually start using get, because we're gonna end up, like in the next video, we're gonna end up having like all the post requests and all the others. And let's go over here and make sure that it is actually visible. It is visible. This is interesting. I thought that my global git ignore would actually ignore the HTTP files. Did I change it? Anyway, just in case, we're going to go to git ignore. Git ignore over here, and we're going to add it. Okay, just in case. So over here. Because I thought that I had, like in my global git ignore, I had it. I'll check later. All right, so just as a reminder, like, we're pretty much done with this video, but I'm going to show you a couple more things. So first of all, we're using the database, okay? So I can just press enter a couple of times over here, and I can go into main Postgres skunk, right? So this is the main that is exposed over, through the regular terminal, but it still talks to the database, right? So if I do show all, it will show me exactly the same to do. So we can actually go and create, and can say, okay, we have buy milk. Okay, so let's do buy more milk. Okay, we're gonna put something in. I'm gonna put August. What's today? Today is August 9, and we have 11:37, like this. Okay, so if we do show all, we're gonna see it here. But if we close this and we just go to client HTTP, show all again, and it should pop up over there, right? Because it's exactly the same database. Okay, great. So we're pretty much done with this video. Let me quit this one. Let me cd into main HTTP. This one, let's actually stop the server. Let's go back to root. Let's start compiling everything, even the test. So the last thing that we're going to do is we're going to basically copy paste a bunch of things. Copy paste a bunch of things. Well, not a bunch of things, just a couple of things, right? Because we also have this one, the one that is exposed over HTTP but does not use the database. Okay, so all we need to do is we need to go and copy stuff from this main. Okay, so we're just going to go over here. We're going to say new file, and we're going to say source main Scala com dev inside you to do and CRUD, and inside of it is a dependency graph. Let's start with a dependency graph. Dependency graph.scala. All right, so like this package and like this package. Okay, so in this particular case, we're going to go to the dependency graph from the regular main, from this one. We're going to steal it, paste it like this, right? Because for this one, we need, we need the pattern, we need the console, we need the random. What am I saying? No, it's HTTP. We don't. So we're gonna throw them out. What I wanted to say is that we don't need the skunk thing, right? So we don't need this is the wrong one. We don't need the session pool, right? So we don't need this resource. Here was a session pool. Okay, so we're just gonna have this, and we're going to remove console random like that, and yeah, so this is pretty much it for the dependency graph. All right, so now let's go and grab the program. Which one are we gonna grab? We're gonna grab this one. I think we're gonna grab this one. Okay, hold on, but this one creates a session pool. I'm just trying to figure out like which one we will end up copy pasting less stuff. What's the regular main? This is over here. Dependencies. I'm gonna click on to do and paste. All right, so we don't use the data. We're not using the database, so we don't need the notches trace. Okay, we don't need the resource. I believe we can pretty much just remove the session pool, right? Can we just do that? Can we just do that? Okay, too many arguments. It just wants the pattern, I think, right now. And yeah, that's it. Let's see. Do we need Scala concurrent and all that stuff? I believe we do. We don't need the context shift because it was required only for Postgres. Okay. All right, what's left? So we have the dependency graph, we have the program. Okay, so the only thing that is left is the main. So we can pretty much grab this main over here and paste it over there. All right, let's go over here. Okay, we can pretty much remove this and the rest should be fine. Okay. Right, so that's it. We can pretty much run it, but as of right now, we don't have any routes to add anything, and this one doesn't use a database. And so, if we switch into main HttpApp/http4s, I mean, sure we can run it, but if we're gonna go and say, where's the client? Not this one, client.http. Okay, but if we're gonna say, like show us all to dos, it's gonna say that there are no to dos. Okay, and yeah. That's boring for now. Okay, but I just wanted to add it because we're not going to touch it anymore, right? So this one, this part is already done. So the only thing that we're going to do in the next video is we're going to basically just finish the routes, right? So this is the only project where we're going to work on, right? So these parts are not going to change. Well, actually, we're going to refactor a little bit, a couple of things. So they're only going to change because we are refactoring things. Okay, so this should be enough for now. Let me look through everything that we did. Let me actually stop the server. Restop. Okay, so yeah, just in case, let me check that everything compiles. Let's also check Scala FMT. All should be fine. Right. So tiny change to git ignore. Build SPT. That's fine, that's fine, that's fine, that's fine. It's fine. Client HTTP, HttpApp. Okay, that's a new file. Super tiny. Server, super tiny as well. Controller. Yeah. As you can see, I'm not super careful about checking every tiny little detail. I just want to see if I did something obvious that is wrong. Dependency graph, main, program, main, program, Like we mostly added stuff, right? There's nothing that we, that we removed. We just created a bunch of new files. All of them are very similar, but they have like these slight variations. Plugins. All right, that's it. So we can go over here and we can do gcam, and it's going to be video 13, part 11. Let's see. Yeah, that makes sense. Okay, let's push. And let's go and check it after it's pushed like this. And we can go here. We can pretty much just go to commits. No, commits like this. All right, that's the one. Okay, there we go. Nice and beautiful. Just added a bunch of things. Most of them were copy pasted actually. They just have like slight variations. And yeah, that's pretty much all I have for you today. For now, as always, it's been Vlad, DependencyGraph.com. Don't forget to like this video if you did, subscribe if you want to improve the developer inside you, and if you learned something today, consider support me on GitHub sponsors or Patreon, and watch my videos weeks or sometimes even months before everyone else. And most importantly, take care.